Hello everyone. Let's start learning Ensemble learning today. So we have to understand what Ensemble methods are, what is Ensemble learning as a model, and we also have to understand how to work on with these models with the code. Okay, so we'll have a look at the project at the end, but let's first understand what this Ensemble learning is all about in machine learning. Okay, so Ensemble learning is about when you combine multiple models to obtain a better perspective. Okay, ensemble learning combines multiple hypotheses and multiple prediction to make a global hypothesis, right? It's just asking, let's take example. For example, you are going to swim in a water. Okay, it's a lake, and you have to decide whether there are poisonous snakes in the lake or not. So ensemble learning is very easy to understand in this perspective. So you are standing near the lake and you have to understand whether there are snakes or not. So there's one person that is coming on your way. So you ask that person. Let's say that is a model. You ask a model whether this lake has poisonous snake or not, and that model says no, and you jump in the lake and you're gone because obviously they were poisonous snakes, right? That was because of that model that gave you advice, that gave you prediction that there were no poisonous snake was weak. It was not very good with that accuracy, with its knowledge base, right? So what does ensemble learning helps it here? So it basically says, let's not ask only one model, let's ask multiple models. So you're going to combine multiple models together to make a prediction, global prediction. So instead of asking one person, you ask 15, 11, 12 persons. And then you make your decision, okay, fine. These many people are saying there are snakes in it. These many people are saying there are not snakes in it. And my global outcome, my global result will be yes, there are snakes. So I'm not going to swim in this water and you save yourself. Okay, that somewhat relates to the concept of ensemble learning, but not entirely. Because we'll see in the diagram that in ensemble learning, we create multiple models, but the first model that runs within in the entire architecture that does not get the entire data set. It only gets some part of the data set because of something called bagging and boosting. So let's discuss bagging and boosting very quickly, right? Okay. So what is bagging and boosting? Okay. So before that, typically combining multiple learners, like maybe this can be different algorithms like decision tree, it can be naive classifier, it can be something else. It is generally what ensemble learning includes. It tends to overfit very quickly because you are typically training it for too long, and yeah, the models are basically when they are put together and on a small data set, they tends to overfit very quickly. So let's understand the Bayes optimal classifier. Here's the model for you. This equation shows the naive Bayes algorithm and the classifier based on the algorithm for the outcome value y. And here you understand what is bagging. So let's understand what bagging is. So bagging is a concept of taking the data from a main data set and putting the small amount of it inside a smaller bag. You can say, okay, you're going to have multiple bags. That depends upon how many ensemble learner or how many weak small models you're going to create inside the ensemble learner, okay, inside the entire architecture. So if you are deciding to create, let's say 14 different models you're going to use, 14 small models, then you will have 14 bags, and each bag will have randomly taken data points and equally divided into all the data bags, right? This process of randomly taking data points from the main data set and putting them into a small data set called bag is called bagging. Okay, now we'll understand how this goes. Here is some equation for you to understand the same idea that I presented in front of you. So here it is. You start with I, it goes till M, and you choose for each classifier C1, right? So let's do that. Boosting, we'll talk about it in the diagram. It's just about increasing the weight of unclassified data. So when it is kept into the next model, it is definitely get classified, right? So boosting was put up by Sapphire by 1989, and it is still being used because back then there was no technology to implement this kind of architecture. But now we can definitely implement this kind of architecture. So what is AdaBoost? AdaBoost is the main algorithm that utilizes entire implementation of ensemble learning, including from bagging and boosting and also classification. So the diagram we're going to show, I'm going to show you next, will be of AdaBoost algorithm. This is AdaBoost algorithm. Okay. It is made up of very weak learner. So as you can see in this diagram, we have basically this data set, okay, and this data set has, let's say, 90 data points. We're going to create 3 bags here, and each bag will receive randomly picked up 30 data points, and you're going to store in them. We have E1, EN2, and EN3 as ensemble learners, small weak models. These models don't need to be very strong. They don't need to be very high accuracy, like 80%, 90+%. They can be just above average, just above 50%, and still they will be used. The global hypothesis that you will create will be very good. Okay. So here's a diagram for you, and in this you can see we have these 3 bags. Each bag will give data to the each respective classifier. So we have EN1 classifier, which will get the data from bag 1. We have E2 classifier, which will get the data from bag 2, and we have E3 classifier, which will get the data from bag 3. All of these classifiers will do classification on the dataset and will save the output in the global hypothesis or global prediction. Okay, they are not very strong, so often they will make mistakes. They will leave some unclassified data because their accuracy is not good. So let's say if their accuracy is only 60%, so out of 10 data points they will only classify 6, they will leave the 4, right? For the left out data, what we're gonna do is we're gonna basically increase their what we call the weight value of the data point, and we're gonna put them into the bag of the next ensemble learner. So whatever was missed from the ensemble learner 1 will be increased in its and in its weight value, and will be put into the bag 2, and whatever is missed in classification, whatever is the unclassified data point in ensemble number 2, inside EN2, will be increased in its weight values and will be put into bag 3, and then EN3 will do the prediction on them, and the respective classification on them, and will store the data into global hypothesis. Right? This is how the entire architecture works for ensemble learning. Okay. Okay, we're gonna see this in action in our project, right? So we have this algorithm here for discrete AdaBoost algorithm and real AdaBoost algorithm. You can have a look at it, right? Let's just directly go towards the our project. So I'm gonna start our Jupyter notebook. We need Jupyter notebook for this project. So let's do that. Let's start Jupyter notebook. All right. So now that we have started the Jupyter notebook, okay, what we're gonna do is basically I'm gonna make it full screen, and let's go to the desktop. Okay, and on the desktop, let's just go to one of my batches. Go to bagging and boosting. Let's click on classification using AdaBoost, and this is your main project. So at the top of the project, this name is classification using AdaBoost algorithm. It is using a dataset called adult.csv, which is going to store the respective values. We will have a look at this dataset also. So at the first cell in the data frame, in the Jupyter notebook, we have imported all the libraries and all the modules, right? We have imported pandas, numpy, zmod, which you clearly know by now, right? We have also imported the ensemble learning algorithm, which is the AdaBoost classifier, okay? And then we have read the dataset using the pandas read_csv function. We checked the head of the dataset with only 2 values, and we can see it is all about the age of the people, their working class, okay, their education, what is their marital status, occupation, relationship, and how much is their income, whether it is above 50k or less than 50k. Okay. Now we will utilize this to understand the differences, and to basically our objective will be to predict whether that particular employee or that person who is having this much age, this much education, this much marital status, this much occupation, relationship, race, sex, and capital loss, capital gain. We will understand what kind of income we'll have, whether it will be above $50,000 or less than $50,000. Okay. So let's quickly have a look at the data frame to describe command, and you can simply see the standard deviation value for each respective numerical column, and the minimum and the maximum value and total count also. Right? Let's understand how many columns are there. So in this data frame, we have these many columns: age, work class, okay, uh, education and all that. Let's have a look here. The first thing we're going to do in this function is showing you very clearly here is basically we are replacing the income with the integer value. So if the value is above 50k, it is going to store 1. If it is below 50k, it is going to store 0. Okay. Here we have declared a function, and this declared function is one of the very, you can say, a very intuitive and very smart piece of code you will ever see. What is going to happen here is it's going to take input in the data frame name and the column name of the data frame, and it is going to store them into two respective lists. Okay, so list 1 will store the value from that particular data frame, and list 2 will store the respective income income and its mean and multiply by 100 of that particular data frame column. So you can have a number of education with the respective income for that education. You can have sex, male or female, and the respective income with that. Okay, so we can change these things in the data frame and the column, and according to that, it will plot them into the bar chart. See right here. Okay, so first of all, we are calling it with this data frame name adult.df and the column name as sex, and here you can clearly see that male receive higher salaries than female, right? And it is a very we can say one of the very important indicator of the gender gap we have in the society, right? So males are receiving around $30,000 and females are only receiving around $10,000, which is not good. You can also see the values here in the annotations also right here. Okay, now have a looking at we are just declared this function again, and this time we are also keeping things in mind that we will visualize correlated with the income. So it will show us the percentage of the income people who are getting more paid or more income above $50,000. So you can see here in this diagram when we run this code. So in overall, this is the situation right now. Okay, males are oftenly around this 30 and something, and females are right here. Here are some simple count for you. So we are just segregating the results on base of sex. Moving on, let's segregate them on the basis of education. So when you do that, okay, so when you do that, you will see that right here, people who are, let's say, doctorate, who have done their PhDs, and people who have done their, professionals who have done their professional schools, and they are often getting paid like $70,000 and more. So the third largest paying job will be the people who have done masters, and the fourth one will be who have done bachelors. Okay, so yes, so professional people and doctorates are holding more than $50,000 per annual income. Let's correlate that with the marital status. So obviously, if you are married, then you are obviously going to get higher income. This is what it shows here. Let's correlate with the occupation. So people who are into kind of job, let's say, right here, professional specialty is highest paid job, and executive managerial post right here, right? Okay, let's visualize them with the basis of work classes. You can right here see that self-employed people, that might also include businesses, are highly paid, and federal governments, and then comes state government and local government people, and also private sector right here. All right, moving on, you can see we have to deal with something called missing values. So in our data set, if you go at the top in our head frame, you can see there are somewhere written question mark, and you are mostly seeing this question mark in the occupation and work class dimension of the data set. So we have to handle it. Normally you would see that whenever there is a missing value, you will find NaN, right? But that is not here. Instead we are having question mark. So for that question mark, we have to handle that question mark. So we're going to do it very smartly. The smallest piece of code going to do the job, and as you can see right here, we did that. So we're only going to store the values in this new data frame, where the occupation is not equal to question mark and work class is also not equal to question mark. So where these respective columns value in the row is not equal to this, only those rows will be stored into adult.df. and that's how we are just filtering it out. We are not removing them, we are just filtering it out. Okay. Then we are just handling their what we called feature engineering. Okay, we are just doing the feature engineering. Although we can use label encoder here, but we are using here get dummies, which is pandas based function. What it simply does, it replaces every row with the column, right? So you can understand it like this. Let's understand what get dummies does. Okay, I'm gonna show you that example right here. So let's see. I'm going to write up in Excel just to make you understand what get dummies function does for you. Okay, so let's open a sheet. All right, so let's say we have here patient ID. Okay, yeah, so we have patient ID and we have result. Okay, patient ID is number 1, patient ID is number 2. Patient ID number 1 has, let's see, cancer. Patient ID number 2 has, let's say, diabetes. Okay, now this is right here a categorical data. We need to understand it, we need to fix it. The one way to fix it will be basically doing this. So you're gonna replace these things, these rows, you're gonna put them into the column. So I'm gonna put here, and I'm gonna put this right here. And patient ID 1 has what? Cancer. So on the place of cancer there will be value 1. On the place of diabetes, because he doesn't have diabetes, so it will be 0. Right here it will be 0 because he doesn't have cancer and he has diabetes, so 1. This is how we handle categorical data, because our algorithms only understand numerical data, right? So this is what we're going to do with these functions. With get dummy is going to do the same thing. It's going to put them into the respective columns and you're going to make a new respective data frames. Then we'll also check the head for one of those. So as you can see, it has done the same thing, right? So let's say person number 3 was divorced. So in front of divorced, the value was 1. Other than that, everyone is 0, 0, 0, 0, 0. Okay. Now we are doing here just defining a function to put a continuous value into the bins when we want to plot it. Okay, and we created this particular you can say right here a data frame. So it is gonna store the values with a particular alphabet and their respective sequence number. So like 0, 1 to something correctly. And yeah, so let's go down and let's just use it. So first of all, you're gonna see the capital loss and its values when we run the row describe command. We're gonna also see again the head of the data frame, which is now this. We have removed all the missing values with the which having question marks, and we are right now plotting the capital loss with the respective you know graph. So right here you can see this is the capital loss overall in our data points. We are putting it as we are shorting it before doing it, so it appears as sequential model as a sequence. Otherwise the values will be here and there and you won't be able to make sense of it. Then we are actually doing here is just checking it again for the capital gain. We had to calculate it using this capital loss right here, and then we again shorted it to visualize the capital gain from the data points. Right? We just saw head of the capital gain and gain dummies when we feature engineer them. So this is gain dummies dot head. This is how it represents it. All right. Let's go down here and you can clearly see this is where the main thing is happening. So we have right here, we are combining all the data frames that we created into one data frame, as you can see. So pandas.concatenate kya karta hai? It concatenates every data frames, okay? And in the Y we are putting income, okay? Now we just splitting the data set. So we are making X train, X test, Y train, Y test with X and Y, where the test size is
90% are the train and 1%, 10% will be test.
Right. So train size is 90% and 10% is this. Random state is 1, so it doesn't keep the data points as sequential. Then we are importing here AdaBoost classifier, and here the random state is also 1, and number of estimator is 11. what this means that in our diagram, if you go back here, these models are 11. Okay.
So how do we know that exactly we have to put the 11?
It's all based on a trial and error method, whichever gives you better accuracy. Generally, you try to keep it above 5, above 7, and less than, maybe you should not go too much like 23, 24. It will slow down your system too much, or unless you're using a server or something. Okay, so we are training that on X train and Y train, and it is trained. Now we are predicting the accuracy. So we did the prediction here by model.predict function by on X test, and the accuracy is 83.69%. You can also print out the output right here. So this is global hypothesis output, right? And it is going to be generally more than what individual model would have been able to do. That's why we need ensemble learning. Okay, just combining multiple of data points, multiple of models and their output into a single hypothesis or single output. This is what ensemble learning does. Okay, now if you just go on Google and search practical application of ensemble learning, you will find many resources. So just read some of these articles and get an idea how the ensemble learning is affecting the real world. Okay, there is some paper is also there. You can have a look at it. Just download it right here. You might have to sign it up for free, and so it's a whole process. Just it's a good thing to read some research paper also. I'm not gonna sign in right now because it's a long process to sign up for it. You can go and read a general architecture, general blogs on it. Okay, so yes, ensemble learning is one of the most important arena of machine learning in the nowadays, and you should definitely uh, explore this side of machine learning also. Okay, although you will find that it is more towards it is used more towards in financial models and more towards in scientific modeling rather than in general machine learning applications. Okay. If you have any question, you can email me, right? Sure. I'll see you. Okay, thank you.